ISON has caught our attention.
This is it. This is the big moment.
The rarest of comets.
Living in cold, deep freeze for 4.5 billion years.
It hasn't been around before. It will not be back again.
A creature recklessly hurling towards the sun, taking the world on a roller coaster ride.
Comet is alive. No, the comet's dying. There it is. It's back again.
A lot of times, the sun just simply swallows them whole.
Being hunted by an arsenal of the biggest space scopes in the universe.
We're going to be watching this comet from Mars, from Mercury, from around the Earth, watching with spacecraft that study and stare at the sun 24/7.
Life just got a lot busier.
Anticipated.
Wow, looks like a comet.
For mysteries unsolved.
Comets are some of our best tools in cracking the code to explain how we got here, and is it common that there are other solar systems like our own?
Comet ISON. It's unlike anything we've ever seen in the sky. It's defied experts' predictions time and time again. I'm Dan Riskin at Kitt Peak National Observatory. This is the world's largest solar telescope, and we've been here around the clock as scientists have watched ISON make its perilous close encounter with the sun. But its journey doesn't start there, and its trip to the sun has been nothing short of amazing. Tonight, we bring you unprecedented access to the scientists and backyard astronomers around the world who have been on the hunt for Comet ISON.
Astronomers all over the world are looking at ISON.
It's a one-return wonder.
This kind of comet happens once in a century.
Its origin, a mysterious place 300 billion miles away. A super comet traveling towards our sun at mind-blowing speeds. It was discovered by Vitaly Nevsky.
Semi-professional astronomers in the south of Russia knew the sky that well that they knew that one tiny little dot had moved in from somewhere else.
A nearly impossible sighting from Earth.
Вот какой она была, когда мы ее увидели. Причем это увеличенное изображение. This is my comet.
It sparked a frenzy. Orbiting detectives like Spitzer, Swift, even Deep Impact catch a glimpse. Proof of life that a rare and elusive comet is alive and on the loose.
It seems busy and frantic, but we're calm.
Its trajectory, intense. At every stop, desperate measures taken to try and catch it.
There's something there.
25-minute leg, and then we'll be on your target.
There you go.
All right.
Space science is put on high alert.
Good luck, everybody.
The value of this comet, unprecedented.
We believe that our solar system is actually surrounded by a shell of objects that we call the Oort cloud. We think that Comet ISON is one of these so-called Oort cloud comets.
It hasn't been seen before, so that gives astronomers the ability to better understand the chemical mix from which our solar system formed.
Never blistered by the burning sun, ISON is pristine.
Comets are blacker than coal, and they don't begin to show themselves until they get active well inside the orbit of Jupiter. A comet is sort of an icy dirt ball. When it gets close enough to the sun's radiation heats the comet, and the interior ices start to vaporize.
As they blast off these jets from the surface of the comet, they can pull particles of dust and rock that stream out behind the comet as well. And so this is what drives these long and beautiful tails that we see out of comets.
Now in focus, it has an ice core the size of DC, an expanding coma that has grown larger than the Earth, and a trademark tail that could reach from Earth to Mars.
He wanted a visitor, he wanted to see something that was really representative of the early solar system. ISON's one of those pieces of material. That's pretty exciting.
But its odds of surviving the inferno of the sun? Slim at best, which is why scientists of the sky are lining up to hunt for Comet ISON. Here in Arizona, it's star country. This is an astronomer's paradise. Many of the world's largest telescopes are within just a couple of hours of here. But our hunt for ISON begins a little further east in New Mexico, with a group of scientists who had to act beyond expectations to get a glimpse at ISON when there wasn't time for a spacecraft. These roads don't get traveled much anymore. It's eerily quiet in Fort Sumner, New Mexico. But there's one spot that is buzzing day and night. It's a NASA hangar. But they don't launch rockets here.
NASA has not flown a planetary balloon mission in more than 40 years.
We need to know if it's okay to disconnect the vacuum pump ASAP. Okay. It seems busy and frantic, but we have called. Bliss, we want to turn on the UVVs.
The tension is understandable. They're about to hang $10 million worth of space science from a balloon.
If you have new hardware, sure, I will do that. Yeah. It's big because that's the culmination of 6 months of very hard work.
Pietro Bernasconi and Andy Cheng are leading a proven space science team.
I think that's why NASA came to us to do this. They thought we could do it, and we said we could do it.
But they have to move fast. Comet ISON has breached the inner solar system, and the closer it gets to the sun, the more secrets start to unravel from its icy core.
We had to go with a balloon because nobody can build a spacecraft fast enough.
They're using a telescope that's flown before, and shiny new cameras, one to capture infrared, the other for ultraviolet.
What we want to do is measure water and carbon dioxide. These are two of the very basic volatiles. These are simple molecules. They're found in comets, they're found in interstellar space, and they form the complex organic chemistry that we need to develop life. When these new comets come, we get a glimpse into materials that condensed at the time the solar system was forming and that have been scarcely altered since then. They have not been baked out by coming close to the sun.
Launch is 2 days away. Conditions need to be right. So far, high winds have them guessing. But there's a surprise in store.
We're putting in place plans to handle a Bryson launch tomorrow evening around the 6 o'clock time, shooting for a 6 o'clock launch.
We have this frontal system approaching us this afternoon. It's going to move through this evening, and then high pressure is going to build in over us.
We're looking for those right conditions, and we think we've got it.
Evening launches are extremely unusual in Fort Sumner. As a matter of fact, we tell scientists we just don't do them because it's nearly impossible to get those conditions to be able to launch a balloon in the evening. This may be the only opportunity in the next 5 or 6 days.
Okay, there'll be no other weather briefing. We're going to show tomorrow at 1 p.m. Good luck, everybody.
Full steam ahead. Launch is now in sight.
I'm most nervous about how bright the comet actually will be because it has never been observed in the wavelengths that we need to see it at. And of course, we are flying a new payload, new instruments, and we think it's going to work. We've tested it every way we can think of. Yep, this is it. This is the big moment.
Every minute of launch sequence is planned. One crew picks up the $10 million science payload. Tension is high. A second crew lays out the $500,000 balloon.
This way until we get center with the ground boat.
So far, so good. On the drive out to launch target, there's a problem.
The latch that holds the telescope in place became a little loose before transit. We're worried about it getting stuck, not coming loose. So what we've done is we've adjusted it a little higher so it'll hold a little tighter.
Okay, how long does it take you to do that? 10 minutes.
524 feet of plastic bag material continue to be rolled out. They need to keep moving to hit this weather window.
There we go.
With the fix in place, helium is pumped into the behemoth balloon. It will expand to 10.5 billion gallons and will be nearly as tall as 2 football fields end to end.
Okay, I would say be ready to engage constant drive.
At its peak, it will float 23 miles above the Earth's surface.
All right. There we go.
Telescope deployed.
Yeah, telescope deployed.
Telescope deployed, but that's okay. I think it's going to be fine.
Immediately after launch, the telescope falls again.
It's okay. We're not too concerned. So, in any case, there's nothing we can do now.
They work on adjusting the telescope remotely. Early indications are not good. By dawn, their worst fears are realized.
What happened was the telescope drove past the latch and it got trapped behind there and we couldn't get it out again. We tried for hours, tried everything we could think of, couldn't get out again. And that was the end of the, so that was the end. We can't recover in time to observe ISON again.
It's a tough loss for this team, but while one mission ends, others are on deck, and there is still time. Coming up, Comet ISON's streak by Mars. The rovers look skyward. It's a big enough deal to commission a 747. Oh yeah, check out the scope on this.
Wow, looks like a comet.
I see it.
And getting inside a comet to find out just what ISON is made of.
Oh.
They call this part of the ice cream factory the Nut House. And considering what we're about to do in here, it's a pretty good name. This giant ice cream freezer is kept at a chilly -13 Fahrenheit. The challenge today is to build a 1,000-pound comet so we can find out what's going to happen to ISON when it bumps elbows with the sun.
It's nice to be able to create that frost.
Leading the build is Dr. Peter Schultz, a cometary geologist from Brown University in Rhode Island. He played a key role in the first mission to ever probe beneath the surface of a comet. Give me a recipe. What's going into our comet?
A comet is made of dry ice, which is frozen CO2, water ice, and this is the glue that holds the nucleus together. The next thing is the dirt. Now, this really is made up of cosmic dust. It was formed when the solar system formed 4.5 billion years ago. We had to bury some of this dry ice.
A little window cleaner for ammonia, and our creation is nearly complete.
Dan, come here. I want to show you something.
Okay.
Come back here. All that steam, that's actually gas coming off of the nucleus, and that's the coma. That's the atmosphere of a comet. And it's so dense, that's why you can't see it from Earth. It's hidden behind this cloud. What we do know about ISON is, like all other comets, it's probably 70% empty space. It's a fragile snowflake.
So it looks great, Peter, but I was picturing more of a sphere comet. Why isn't it round?
Well, gravity points down on Earth. In a comet, gravity is pointing in, and that helps to make it into a shape. Okay. We know that the nucleus has craters, but we don't know if they're formed by something hitting the nucleus or from explosions from below.
Like a volcano?
Yeah, but cryovolcanic, ice volcanoes.
Cool. What's this black coal dust for?
Well, this is really how dark a comet really is, including ISON. As the gas evaporates, it leaves behind this really dark dust.
Our comet now has all the elements of ISON. Now, if we could hurl it into space at 100,000 miles an hour and have it hit a planet, something spectacular could happen. Some scientists believe most of the Earth's water was left here by icy comets hitting the planet. At the University of Kent in England, researchers now say comets could have also started life itself. To test that theory, Dr. Mark Price mixes up an organic compound with simple amino acids, the building blocks of life.
The ice composition we made was a mixture of CO2 ice, water, ammonia, and methanol. And then we cooled them down to very low temperatures, and we placed them in our gun and then shot on them with a projectile to generate high pressures and temperatures necessary to synthesize these amino acids. The gun we are using fires projectiles up to a speed of 8.5 kilometers per second, which is the sort of speed that we've encountered in space, and is the sort of speed that comets would have impacted the Earth's surface. The atoms present are ripped apart, and then they recombine, but they recombine in a more complicated fashion.
Complicated enough to become us?
This suggests that if there was a cometary impact early in the Earth's history, such an impact could have been the starting point of life on Earth.
And that means wherever you have comets hitting planets or moons with life-sustaining elements, well, let's just say we may not be alone in the universe. Back in the ice cream freezer, our comet's been sitting frozen for 15 hours. So how does our comet look?
Oh, this is gorgeous. You know, this looks like ISON is passing Jupiter, approaching Mars. And you see the frost here?
Yeah.
You know, eventually, as it gets closer to the sun, it'll start evaporating away. And you can see the frost and these holes on a comet like Comet Hartley that we saw close up from a NASA mission. As ISON starts approaching the sun, it begins to erupt with geysers, jets that carry dust and gas from beneath the surface.
So what causes that?
It's probably from a reaction of warm soils that come in contact with dry ice as it approaches the sun.
And now, to simulate the effects of the sun's warmth.
So let's see what happens.
Oh!
Yes, that's exactly right.
So is it that intense on a real comet?
It is, but it's continuous. It keeps erupting.
But wouldn't that be like a jet engine that would then change the trajectory of the comet?
Not just the trajectory, it changes the rotation, the wobble. Comets are always changing.
And that is why we watch. A celestial event is about to take place for planet Mars.
We at Mars are getting an early look.
A comet preview through the eyes of 2 rovers and a spacecraft.
This is our chance to really get a close-up view of this comet, and that gives us a chance to preview the comet for other observers.
Curiosity and Opportunity have been roving the red planet, but they rarely turn to the skies. Comet ISON is even turning their heads.
We did look from the surface of Mars with our cameras that are on the rovers, but we couldn't find it. The atmosphere was too hazy or too bright for us to be able to see it.
This puts all the pressure on a spacecraft lurking high above, Mars Reconnaissance Orbiter.
Normally, we don't even look across the sky for these kinds of objects and such, because our objective is the planet below us. And so these instruments weren't designed for that, but they're there, and the comet's there, and so we're taking advantage of that.
A $40 million camera called HiRISE has a lot at stake here. It's taken incredible images, but will it catch Comet ISON?
We're looking with our best telescope to see things at a resolution that we haven't seen before on Mars. We started looking for ISON when it crossed what they call the snow line. That's a period when the sunlight should be bright enough that it starts to sublime the ice on the comet, and so it becomes a brighter object.
Any sighting would be news.
Comets are unpredictable, so we were very excited and somewhat suspenseful as to, are we going to see anything at all? But what we've seen is, yeah, we caught it. It's faint. It's at the lower end of the predictions. So that's telling our observers that we're going to have to be prepared, perhaps, for a fainter object than what they were expecting before.
Coming up, tracing ISON's flight path. A crazy speed demon trajectory that makes it hard for even Hubble to find.
It's kind of a needle in a haystack problem.
And ISON's a big enough deal for NASA to order up this 747 to track it. Buckle up. We are inside the tube of the largest solar telescope in the world at Kitt Peak National Observatory. This is the machine that scientists are going to use to watch ISON as it goes around the sun. Now, long before we got to this stage, there was a lot of speculation about ISON, and that's why we headed to the home of the most famous telescope in the universe, Hubble headquarters. Max Muchler is a bit like a detective, lining up cameras and running surveillance, this time on the elusive comet ISON.
Anytime we get a relic from the early solar system coming in and allowing us to get a close-up look at it, it's kind of like a paleontologist finding a fossil.
There have been some reports in the past few weeks to indicate that the comet might be breaking up.
We just don't know what to expect.
Max's team gets to operate a multi-billion-dollar telescope, one with incredibly high-resolution cameras, Hubble. They think they can prove Comet ISON is still out there.
We can take very deep, very high-resolution images and really study the nucleus of the comet.
Hubble last had ISON in its scope back in April.
What really struck me is that it already looked like a comet, even though it was so far out that it had already started sprouting a tail, and there was a very prominent sunward jet.
But now, Hubble has a chance, and Max wants to make sure he lines up the shot perfectly.
We know the comet is going to be here, and we're trying to pick a field that isn't too crowded. We don't want a lot of stars in the way, so it gets planned a few weeks in advance, and then we just sit and wait.
Just like a timer on a camera. And this groundbreaking image gets delivered to Max's inbox.
We get a little email message saying the data's arriving, and I might be at work, I might be at home to get that first quick look. This is what a single image looks like. You can see the comet, but you can also see a lot of artifacts. There's cosmic rays, there's star trails, some of these stars that we're trying to avoid that are streaking because we're imaging a moving comet. It's kind of a needle in a haystack problem.
It's certainly very exciting to see these images for the first time.
Jolt Levay takes Max's image and works to bring out key colors from Hubble's many lens filters.
Our goal is to stay as true to the data as possible, but visualize as much that's inherent in the data. And this is the final result of Hubble's image of Comet ISON.
Back in April, we saw what looked like a jet on the front of the comet. That was new material that had just come off the surface, probably small icy particles. That jet feature is not there now. So what does that tell us? Whatever was coming off the comet 5 months ago is different material than is coming off now.
To me, that's just learning the secrets of the universe, and comets are like a little messenger from the outskirts of the solar system.
Comet dust, possibly granular material, a lot like this. That's what prompted the world's largest airborne observatory to take off after ISON, and only our cameras were there. This is no ordinary 747. Meet Sophia. Behind this door, a 17-ton telescope, making her the biggest airborne observatory in the universe. On the other side, a team preparing to intercept Comet ISON. The flight starts in Palmdale, California, and circles up to Canada and back. Lead scientist Diane Wooden is preparing for an all-nighter.
Dark chocolate, anyone?
A 10-hour flight she hopes will answer some mysteries about ISON.
There's a mystery about why is this comet appearing to be gas-rich and dust-poor. A lot of comets we see, they're about half and half.
Measuring ISON's dust will give Diane clues, not only to where ISON was born,
Those are the deep freezers of what was happening when the giant planets were forming.
in the dark for nearly 1 million years, it's a time capsule that could hold secrets to Earth's beginnings. ISON's dust, especially precious.
But this comet is coming through for the first and only time.
It's considered pristine, not yet damaged by the sun.
It's actually only going through the solar system once. And so this is its one and only time to shed its story.
This flight, Diane's only chance to catch up with it. As the telescope hatch the size of double garage doors opens,
It's only like a 25-minute leg, and then we'll be on your target.
it's the moment Diane's waited for decades.
We are starting the observation now.
Sophia's infrared telescope was born to see things like a comet's tiny cold dust grains, smaller than the width of a hair.
Cooler grains cannot be measured from the ground.
Up here, Sophia's vision is clear of atmospheric interference, a view they can't get from the ground.
We are going to do 12-minute increments of observations. And at the end of every 12-minute increment, we are going to do this telescope rotation. Interesting.
It's one pair. Wow, looks like a comet.
It does look like a comet, but I don't see it. I see it.
What we're seeing here is the comet in the finding guidance camera, and we're starting to take data.
But not for long.
We just lost our connection.
That is not good.
My entire bank here is rebooting. They're going to have to reacquire at least a 20-minute turnaround time.
Okay, to reboot.
Sophia maintenance, are you up on Victor?
It's time they don't have. They're nearing the end of the flight.
Need to get data.
At 19 microns?
Yeah.
We're going to retarget, and we're just going to take some data.
Okay.
It's Diane's first and only chance to chase ISON.
I thought I was seeing something fuzzy over there.
But disappointment again.
We had a circuit breaker blow, and that circuit breaker could not be reset.
Yeah, we can stop short.
We got 3 images in 45 seconds.
Total.
It's around that. I don't know if that's intrinsic to it. 2 positive, 2 negative images of it. That's not a lot there.
It's a small success with a big result, confirming what Diane expected to see.
This comet has a normal grain size distribution, just many fewer grains, and it makes it a gas-rich dust-poor comet.
This is 11 microns.
11 microns.
ISON spewing more gas than dust at this early observation means it was likely formed further out in the solar system, where ice outnumbers dust, a key piece of a bigger puzzle.
This mission is important to the understanding of all comets.
Diane will next compare today's dust measurements with findings from past comets.
Only by gathering information on each comet and then comparing them can we enrich that understanding.
For Diane, it makes today's mission definitely worth the wait. Coming up, nothing like a rocket launch in search of this comet.
Life just got a lot busier.
And ISON's death march is on. It's gotta be feeling some heat. Welcome back. I'm Dan Riskin at Kitt Peak National Observatory in Arizona. Astronomers here have joined others around the planet to track a comet that's really captivated the whole world. All this hour, we're bringing you the inside story on Comet ISON, where it came from, where it's going, and what we're learning along the way. It's an international journey, but not far from here. A rocket recently took science above the skies to get one last look at ISON before its date with the deadly sun. White Sands Missile Range, New Mexico. Sounds of rockets booming all the time. But today, the launch pad is reserved for a special mission, to shoot for a comet.
The $64,000 question right now is what kind of state we're in, whether the comet already has started to come apart at the seams.
Stephen McCandless is a bona fide rocket scientist. He's sent payloads to the skies before, but never this quick. Comet ISON holds special allure, and he's got a payload like no other.
Looks good. Looks very good.
This mission provides an absolutely unique baseline. There are very few space-based assets that can do this.
It's called a spectrotelescope, which can acquire UV spectra and images at the same time.
It was designed mainly for galactic work, where we wanted to be able to look at objects that were widely separated over a half-a-degree field of view, which is the size of the full moon. The microshutter array gives us a capability of targeting up to 43 individual objects.
But tonight's mission is just focusing on one. The science is all strapped on top of the rocket booster and engine that will propel it 185 miles above Earth.
What we're trying to do is get the comet as close to the sun, where the comet is getting kind of maximal heating, yet we still have time to make the observations.
Their timeline is tight. ISON is moving faster than ever and could be swallowed by solar winds in less than 10 days. Stephen has a chance to get ISON's portrait before its final fate.
This comet being dynamically new and coming from the outer part of the solar system, one of the things we want is to measure the carbon monoxide to water ratios. It's a key measurement to be making.
Measurements that could answer just how far Comet ISON has traveled.
We're pretty much done and ready to go.
Launch is just an hour away, but there's a problem.
We're going to put off elevation. Pump is still on.
A valve isn't sealing their valuable payload.
Probably likely to do with the cold.
We want to get all the residual gases out of there and give a chance for all the molecules and oils we have in there to evaporate out. Any contamination of our detector might contaminate our data.
We can try this 1 or 2 more times, but it doesn't look like it's going to go. So I think we're going to have to call it.
Next window, 15 hours later. In mission control, it's deja vu. Tension is high. Stephen waits to see if it works.
So pressure steady. We don't have to worry now about what happened last night.
Launch is on track.
We're fully armed, so once we get down to T-0, they'll turn the key and hopefully she goes away.
There we go.
5, 4, 3, 2, 1. Rock away. Press 5, press 6, press 7, press 8, press 9, press 10. Press 1 every 20 seconds.
Results are immediate.
Got the comet in the center.
The imager caught the comet.
Shoot.
Shoot.
Okay.
That's about right around here. Thanks everybody for all your help.
We still have scattered light in it. We didn't take care of all of it.
Very bright.
It was very bright.
Stephen's hunt for Comet ISON is a success.
No one's ever flown a payload like this before. So to get this close and get the data like this, we're happy.
Their early look indicates large amounts of hydrogen pouring out of ISON, something not anticipated. Is this a benchmark of ISON's state before its last dance with fire?
Oh, I'm not willing to make any kind of predictions. This is a comet, for God's sake. We're pleased that it put on a show for us, and looking forward to seeing what it's going to do on the other side.
While the Fortis team climbs aboard a military chopper to recover their payload, a countdown of another kind is on. Can you feel the heat? ISON can.
We've got a chunk of rock and ice that's 4.6 billion years old, and it might only have 18 hours of its life left.
Comet ISON is nearing perihelion, its swing around the million-degree sun, where it will live or die.
It's really kind of edge-of-the-seat stuff at this point.
I'm almost there.
Matthew Knight is deep inside the largest solar telescope in the world, perched atop Kitt Peak, Arizona. As Comet ISON nears the sun, this is the place to watch its fate.
They get the light from the sun, they reflect it way down this tube and down to the instruments down where we're looking.
Astronomer Casey Lease will soon hide from that sun.
We are working actually below ground.
It's where Carl Battams is using cameras on satellites to track ISON's every move.
This is a coronagraph camera that looks at the sun, blocking the sun with a solid disk. We still don't know what the comet is going to do. It could fall apart, it could be vaporized.
ISON is facing searing solar outbursts and fighting being ripped apart by the sun's gravitational pull. If it survives its slingshot around the sun, it'll have a victory lap past the Earth for all to see.
It could be this fantastic thing in the night sky. We have no idea.
For now,
oh, look at that.
3 of the top sun-grazing comet experts will have the best seats in the house.
This is really the biggest moment of my career so far.
We're now less than 24 hours away from its close brush with the sun.
So as night falls, there are no guarantees tomorrow will go well. As the morning sun forces the eyes of regular telescopes closed, the solar scope wakes for the big day. The 48-inch mirror bounces sunlight to instruments 200 feet underground.
We're going to be taking pictures of the sun and of Comet ISON here. Our job here is to try to see if we can get the temperature of the comet's dust and gas.
When the million-degree solar heat starts roasting ISON, it'll be Matthew's key moment in the sun.
I've been studying comets for about 13 years, and I've been waiting for a comet like ISON that whole time.
Only rare sun grazers give Matthew the chance to detect what comets are made of. The sun's heat's so intense, it boils rock, releasing its gases.
We would be able to detect things like potassium or iron or calcium, which we know is probably there, but it's very hard to measure from the ground. And ultimately that informs how it formed and how the solar system formed.
2 hours away from the sun, the comet is rising to the challenge.
Hey, latest LASCO images, brightening up.
Really?
It's getting really bright.
That's fantastic. Let me know what's going on.
Yeah, we'll
Thanks.
keep on it.
It's terribly exciting, but it's very nerve-wracking too.
Then, a turn for the worse.
The comet is nowhere near as bright as it was earlier, and it means it's fading.
That also means the solar telescope can't see it against the bright sky. So, neither can Casey or Matthew.
It's very disappointing. That's about all I can say about it.
Luckily, the satellite images are working just fine, giving Carl a window into the extremes the comet is facing. As ISON goes behind the sun, it's do or die.
It's feeling extremely strong gravitational pull from the sun, and that gravitational pull is actually stretching the comet. We've now lost sight of it. It could have fallen apart, it could have been vaporized. We really don't know right now what has happened to this comet.
As everyone waits, they're thinking the same thing.
Have we seen the last of Comet ISON?
More than an hour later,
we can't quite believe this, but something has come out.
I'm feeling a lot better than I did a little while ago.
It's like playing the lottery. Although I must admit that I think the odds of winning are a bit higher.
But betting on this comet would be a mistake. In the next hours, it fades out, then brightens again.
This is why this comet is just absolutely killing us right now.
Finally, the comet dissipates and is officially declared dead.
This thing has had me on a roller coaster.
This was a once-in-a-lifetime event, I think.
Who knows if they'll ever see another comet like this again, but ISON's fantastic journey has given them enough data to study for years to come.
We think we understand what it's doing, and of course it goes and does something different. This is absolutely amazing.
When we come back, it may be the wildest ride in comet history.
It's been an absolute roller coaster.
We've got the post-game analysis. And the hunt doesn't stop here.
They tell me I'm crazy. Fire in the hole!
We meet the Mavericks who are already chasing the next super comet. So this has been a pretty crazy couple of days, especially for you, Carl. What has this been like for you personally?
You know, this has just been, it's been an absolute roller coaster. It had been such an intense ups and downs following this comet through this whole journey we've been following it, but particularly the last few days. It's like the comet is alive. No, the comet's dying. It's getting brighter. It's getting fainter. It's truly been the most thrilling couple of days of my entire career.
Yeah, so what are you going to do next?
We're looking at analyzing the data. We've collected the single biggest data set about a comet in history. And that's going to take some going through, and so that's what we've got to start looking at in the future.
Comet ISON's legacy is hardly over. And if you think this comet got a lot of attention, wait till you see what's in the works. A group of comet mavericks looking for the next creatures of the night sky. How do you study something moving 30 times the speed of sound? Well, some of the best minds in the business are facing off in their efforts to catch a comet.
They tell me I'm crazy, and you can't do that, and then they make it happen.
At this former Apollo test site, one team is testing a harpoon to delve beneath the surface of a comet.
The idea is that you would have some kind of vehicle that could hover over whatever you're interested in sampling and send a projectile down into it, grab your sample, and pull it back.
Joe Newth and his team are in early tests of their technology.
So this is our ballista test bed. It's basically just a giant crossbow made of 2 truck leaf springs, as you can see on the bottom, 1/2-inch steel cable. There's a 4-wheeler winch up top, so you can raise this up and lower it. And it basically works like 2 fingers would on a bow and arrow.
The target? A range of materials to simulate the surfaces that might be on a comet. Their challenge is to perfect the delivery and retrieval to bring home a perfect slice.
The sand is very fluid. The pebbles are not.
Starting to load.
We want to test this system as far as we possibly can. And the pebbles are a realistic worst case.
Shot at 550 into pebbles. We're getting ready to fire.
All right, it's stuck in.
Moving this harpoon closer to its target.
Happy, happy, joy, joy.
Jessica Sunshine's plan is to hop across a comet.
Ours is a spacecraft that hops from place to place in order to explore all the different terrains that exist on a comet. We come in very slowly, like a butterfly settling on a branch, and try to keep forces as low as possible so that we don't have any sort of rebound effect.
Nothing like last year's violent Mars landing.
When people think of landing, they think of Mars, 7 minutes of hell. We have more like the 1.5 hours of tension.
Tension is a given on another critical mission over a decade in the making.
Rosetta is a major initiative by the European Space Agency with a NASA collaboration. It is the first time we are going to bring a major spacecraft like this for the exploration of a comet.
Rosetta will rendezvous with Comet 67P after a decade-long journey. Once it arrives, it'll hitch a ride for a trip around the sun.
In 2014, we will be waking up from our deep hibernation that it took to get out there that far. We'll be landing on the comet. Whereas some smaller missions might only carry 4 or 5 instruments, we are bringing almost a whole laboratory to the comet.
These missions won't see results for a while, but true innovators keep up the hunt, one crazy but plausible idea at a time.
We really can't wait to get to that spot where our way of thinking about these objects is changed forever.
What an incredible ride. This 4.5 billion-year-old relic from our outer solar system has died a fiery death right in front of our eyes. We may never see anything like this again in our lifetimes. Scientists are going to be poring over the data from ISON for decades, and for the rest of us, it's just a nice reminder that the universe is still full of surprises. From Kitt Peak National Observatory in Arizona, I'm Dan Riskin. Good night.